Hi my friends, I decided to present you some new models to learn more about Autodesk Inventor in addition to the tutorial number 001. Go ahead and enjoy. Today we model this part. It has some interesting features, as you can see, and I hope you'll like this model. The drawing is here, and you must be careful because there are some tapers at 2 degrees placed to 2 features. You see the mid contour of them. These are the 2 tapers. Let's start. New standard millimeter SIPT, new sketch, XY plane. We start with this diameter of 84, this dimension of 44, and this radius 25. Circle 84 diameter. Home to see all the circle, and now we keep pressed the left button of the mouse on the circle and we can draw a tangent line. We apply again, click on the left button and we can draw an arc. We go here trying to catch that tangency, or we place it here and we apply constraints to both ends. This is one, this is the other one. Trim to cut this segment of arc. We use the vertical constraint to place this point on the same vertical with the center point. In the previous tutorial I mentioned the work planes, work axis, and the center point. This is the center point. The other dimensions are from this point to this arc. You see, you can select arcs or center of arcs. 44 is the dimension, and this is 25. Finish sketch, F6, and now we apply extrude of 32, being careful with the taper. Extrude symmetrical 32, and now we can use this option of taper, or we can click on this sphere and move to the left or to the right. We want to be to the left, and the value here must be 2 with minus. You see here -2, this option. Okay. The other major extrusion is this one with the thickness of 14. It has also the taper of 2 degrees, radius 16, and angle of 7. The distance between these 2 points is 125. Okay, we use the plane XY, F7 to see inside, then we draw lines and arcs. This is a horizontal. We keep pressed the left button of the mouse and we go here, then back to the bottom line. You see we have here 2 constraints and Inventor waits for us to place 6 dimensions. Take a look. We place this point on the same vertical with this point. Now we have 5 dimensions. Then we also place this point on the same vertical with this. Now we have 4 dimensions. We apply 16, radius 16 here. Everything was scaled because this was not connected with any point here as a dimension. Now we place the distance between this arc and this point of 125. Two dimensions needed. One of them is this, where to place this. We can place this anywhere inside this contour. To select a point inside this contour, we project this any circle. Here we have 2 circles and we have here a point. Then we make coincident this line with this point. 1 dimension needed. What is that? The angle, my friends. 7 degrees. Now we have a fully constrained sketch and we can apply extrude. Extrude of this all area, symmetrical, 14, everything is already placed because I created this model before. And we place here again -2 for taper. Okay, you see that contour around the part. We continue with this cylinder. It goes from here to here. Dimensions are diameter of 30, placed at a distance of 39.5, and 2 dimensions, 37 and 49. Let's do this. You see 37 is the distance between these 2 lines. We create a new plane based on this work plane to the right at 37. This is the base for a new sketch. The new sketch is a circle with diameter of 30. F7 now to see the center point or projection of the center point. We place on the same vertical this point with this point, but we have to know that Y is horizontal and Z is vertical. Always we select horizontal to place that constraint to be on the same vertical. We can rotate, and this is vertical and this is horizontal, but let me use this. The distance between the circle and this point is 39.5. Finish sketch. I can hide this plane and I apply extrude to this direction at a distance of 37 plus 49. We can use expressions, mathematical expressions, always in Inventor. Okay. Next is this internal void. You see here. You can also see the part. This contour has dimensions, of course. What dimensions? Well, this is diameter of 62, 26, and the distance of 55 here. Don't forget, there are two fillets, radius 1 here. We use this face to create that circle with a diameter of 62. Then we create a rectangle with a thickness of 26, and we place this point coincident with the center point or the projection of the center point. This distance is 55. We have a fully constrained sketch. Finish sketch, extrude, I select the circle, I select the rectangle, I apply cut, not join, and through the part, all the way through the part. Okay. We don't forget that two fillets of 1. We click on an edge and we place dimension of 1 millimeter. Another fillet is also 1 millimeter. Another feature is this one. The drawing is with 60.5 from the center to the face, radius 14, and this one 33 to the center. Good. Plane, XZ plane, up at 60.5. This is a plane for a new sketch. We project geometry, this face, and now F7 to see inside. This is important because we can start and go back from this line. We press the left button, we go here and back to the projection. We also connect these two ends. Dimensions, this is radius 14, and the distance to the center point is 33. X is to the right, so we use horizontal for these 2 points on the same horizontal. Extrude to this cylinder. Okay. Visibility. The cylinder has 2 holes, one of 13 and the other of 13.8. Hole is the tool. We have to select positions. We select a face, we select a center, and a dimension. 13 is the minor dimension. Then we turn the part, we select the face, we select the center, and we change to 13.8, but with a limit to here. You see? Okay. Another hole is this one, metric 10 plus 1. It is placed in the center of this feature. Hole, threaded, isometric profile, 10 is the diameter and 1 is the pitch of the thread. If you take a look here, you see a dimension of 10 for the thread measured from up. Okay. We select the face, we select the center, and we place here 10, and the end must be in the internal hole. We select the surface to be this one. Why? Because this is 13 and this is 10, less than 13. Okay, you can see the thread on 10 millimeters. Another hole is this one, 15, through the superior feature. We use the same tool but not threaded, and through all the part. We select the face, we select the center, and we place the dimension 15. Okay. Other holes are these 5 holes of 4.3. One is here at 60 millimeters, and the other are placed on the circle with the diameter of 71 and placed at 45 degrees, equidistant. We select the face, we draw 2 lines, one is this one and another is this one. The length or the radius is 71 divided by 2, tab. Now I go to the angle. You see this is respected even if I move outside this, and here I place 45 degrees. We place two new entities, 2 points, then we apply the circular pattern for this point about this center, not 6 but 4. Okay, finish sketch, and now we select whole, and you see 5 positions were selected because of that kind of sign, a point. We have to place only the diameter, 4.3, all the way through the part. Okay. Chamfers, you see, a chamfer is here, another here, also at the ends of the 2 holes, with different diameters, dimensions. This is 1.5 at 45, and the other are 1, 1, and 1. We start with these 2 at 1.5 because they are on both sides. Apply, then I change to 1 and I place that chamfers at the ends of the holes. Okay. The last feature is this hole. You see, it is a sloped hole. We have dimensions, metric 10 with a pitch of 1, just like this one, at an angle of 15. Now we apply a special procedure. We use the plane XY, F7 to see inside. We project this circle. We draw a line starting from here to that projection. We apply dimension of 15 between this line and the axis X taken from here. This is 15. Then we transform this line in an axis. You see, we have here axis and point, like this one, work axis. We create a special work axis by selecting this line. Now you see a line here, the axis. Then we place a point on this axis and this face. You see the point here. Having this, we select hole, threaded, 10, not 4.5. We select this point, we select this axis, and we change this by selecting this face, and the thread is full depth, not limited at a dimension. Now you see we'll have this hole. Okay, I hide the sketch, visibility, not delete but hide, and the axis. work axis. Now, reviewing the model, I found a mistake. This chamfer. We can modify this because the problem is here. You see, I selected this plane instead of this plane. To repair the problem, we disable this face and we enable this face. Okay, now it's okay. Let's verify the volume. We select the name of the model and properties, physical, update. We select the result, close, drawing, double click, and we place the new value. There is a small, very small difference, but we keep this and we erase the previous value. Both are made by me, and now I used probably other solution, minor solution. Material is steel carbon. Color is red. We use view to hide the edges, and we select default lights. Now we select some faces to apply machining. This is one. I press the shift button to select some of them. You can select any one you want to be still polished. That's all for today. Thanks for watching. Bye bye.